afternoon. It seems to be the story of my life that I always get the after dinner spot or the after lunch spot. So I'll try and make it interesting, and I'll try and run through at a reasonable pace. What I'm going to do is just talk about our experiences and an architecture that we've developed, which we've just completed the project, which was to build a strategic platform for our business that creates a data processing platform that works across a variety of different marketplaces, different propositions and customer sets. So who are Transactis? We're specialists in the UK at processing personal identifiable information, so particularly names, addresses. We do that for a variety of large organizations in a variety of sectors. We do it for the government. So HM Customs, we're the only people who hold all your tax records in the UK outside of central government. We provide very bespoke and very tailored CRM solutions, which are either for marketing purposes or for anti-fraud purposes. So the project that created the opportunity for this platform was to develop an anti-fraud service primarily for the retail sector, but that could also be used for insurance, logistics, and other sectors. Essentially, organizations give us their transactional information about goods sold, about goods shipped. We then match those, that information to a set of known identities. So we carry about 70 million individual profiles of people in the UK. And what we do is we consolidate that information that comes from that transactional data, which arrives in a number of different formats through a number of different mechanisms. We consolidate that into a syndicated data pool. Then people who are subscribed to the product can then use that information for multiple purposes. So we derive several hundred different types of indicative figures, which might be to do with first or third party fraud, it might be to do with people claiming goods lost in transit. So we can use that information to provide indicators to retailers at registration of accounts. If you're going to give people credit limits, we can do it as part of the payment cycle, or we can also do it as part of the delivery cycle in the logistics operation. To put some numbers around that, we have about 70 million identities. The databases behind it are somewhere in the region of 10 to 20 terabytes on day one, and we're expecting to process somewhere in the region of 100 million transactions in the first year. So the challenge, or the opportunity, depending on which way you look at it, is to take this business opportunity and use it to create a strategic platform for the business. So traditionally, the organization has built a single stack solution. And this is not unique to us. It's quite a common thing in all industry sectors. Traditionally, organizations have built the single stack solution at a software level, even though they're doing comparatively analogous processes and data transformations across different opportunities. So we have a number of different large data pools. We have a number of different customer specialist solutions. And we're effectively, every time, building a whole new solution. So it's expensive, it's slow, it's expensive to operate, and it means that we get long lead times, which is a barrier to us being able to win more business. So the strategy is very much about building a single software platform that will sit on top of a virtualized environment that we can build all our propositions on. So effectively, it provides multiple propositions to the marketplace for multiple clients using essentially a core set of services that are configurable in a way that makes them flexible for different contexts. And I also can't go to my customer base and say, I want to receive all the same data for each proposition. Or even within a proposition, I can't say I always want the data in a certain format, whether it be real-time batch, whether it be to an EDI standard or any other form of data format. So my solution needs to be data agnostic. Goes without saying, it needs to be high performance. And it needs to be able to do common, complex data processing algorithms at speed, and it needs to be able to do them in a way that's tailorable and configurable for every single customer. So there's a number of architectural challenges. So if I'm going to build this platform, I'm going to leverage this project to achieve that objective, and essentially I'm implementing an IT strategy by stealth. So the solution is very much a layered SOA architecture. The key focus is to get extensive separation of concerns and to make sure that what we're doing is we're isolating out different aspects of the solution so that I get that reuse that SOA often promises but fails to deliver on. So there are 4 essential layers to this architecture. There's the integration layer, which is about abstracting out the method and the format of the data being transferred into and out of the company and turning that into a canonical form for internal consumption and processing, and also abstracting out any form of batch stroke online real-time differential. We've then got a service layer, which manages the orchestration of the business processes and provides a variety of services that deliver the complex data processing and matching. They also create the derived variables that create the indicators, either for marketing purposes or for fraud purposes. So there can be several hundreds of those, if not thousands of those, for some of our propositions. And finally, we've got, in the main stack, we've got a data store arrangement. And so what I do is I store the data in a set of separate schemas which are based on the orientation or the purpose of the data, not the proposition. So, for example, personal identities are stored as a central definitive library of what we understand to be the identities of individuals in the UK. We then might have separate domains for marketing or for fraud. And an individual proposition might dip into all or some of those data stores and assemble data across those stores into a response back. The 4th layer of the architecture then is the operations framework. It provides the event management, the error logging, dead letter queues, and all the things you would typically expect to see in an architecture like this. The whole thing, after the integration layer, works to a canonical data definition, which is internal to us and abstracted away. And all services and messages are versioned within the architecture so that I can actually uplift capability for a particular circumstance in isolation without having to uplift the capability for all clients. So again, I don't want to have to uplift an address match for all my clients at the same time, because some of my clients might be quite happy with the functionality they've got today. So this idea of versioning of the logic is quite a powerful tool for us. So the other key architectural characteristic is because of the volume that we're going to put through this, and as we put more and more of our solutions onto it, it has to be able to scale horizontally, and it has to be able to scale horizontally in a fairly predictable and consistent manner. So it's a complex architecture. It would be really easy to get it wrong, and it would be very easy to fall into a number of the design traps that people classically fall into. So we've used a consultancy organization that we know well called Pasca in the UK to help us build this design cycle and this architecture. So picking out some of the sort of interesting aspects of the design, one of the really interesting aspects of the design is the way we manage work types. So I'm running multiple activities or business processes through the solution. And one of the key things is, how do I design for reuse? So we have essentially multiple deployable components. So the core framework and the common services are deployable as one component. Then for each proposition, we drop a deployable proposition schema into the architecture. Now, the advantage of this, it means that if I ever wanted to create another secure domain in a separate stack for a specific client, I can actually lift those components up and put them back into a secure domain, for example, for government purposes. So a message comes into this architecture off the back of the interface layer. It's been normalized into a canonical form, and we use the header information that's in that message to control all routing and all orchestration of the messages. So effectively, the execution layer pushes it into the right orchestration method for that process, and the scheme services and the common services that need to be consumed to process that data are processing in real time. Now, it's worth stressing that some of the process chains we're running are several hundred stages long, potentially, and they're also iterative with the existing data sets. So this is not a simple transaction that we're potentially executing here. With respect to how we control the service, all the message header information is versioned, so the scheme, the customer, the message ID, the work type, that's within the message. The services are written for common use, and the service messages and schemes are all versioned. So in the first release to deploy the first proposition, we deployed it in the region of about 80 services, which was the first phase, and we're expecting the complexity of the platform to grow as we put the propositions on there. So the technology base, why WSO2? There were really 3 reasons why we picked WSO2. The first is that it's a comparatively comprehensive platform for our purposes. It covers most of the things we want to do. There were some specific things for our particular need, which we chose to use other components. The obvious one being we put Altova MapForce in for our data standardization, which was purely a function of throughput for some of the batch processes we were running. But largely, we've used WSO2, and that attractiveness of the full range of the product was something that worked for us. And we think that WSO2 will grow as the platform goes as well, and that will be advantageous. The second thing is that WSO2 is fast. As far as we can see in our initial assessments, and then as we've gone into our performance testing, it has a performance characteristics that suits our need. And then the third element of the key elements is the price point. So if you're doing a virtualized software environment on top of a virtualized hardware environment, as most of us know, the licensing for a lot of product sets can be very difficult in terms of getting a cost-effective price point for the capability you're building. If I'm building this as my strategic platform, and I don't know how large the eventual scaled solution might end up over the years, I need something that gives me a very effective price point, and WSO2 gives me that. So those things put together give me a really good platform, and because it's a strategic platform, I also need the comfort and the confidence that the commercial support arrangement gives me. So I put all those things together. It worked well for us. So if that's where we are at the moment, I'll just pick out a couple of the interesting things that are going to take us on the journey going forward. So the ability to have flexibility in processing paths is important to us. The ability to have flexibility in data manipulation is also important. And one of the things that we've created the opportunity to do is to get very late binding between data processing rules and the execution of a message. So in one of our new innovations, what we've got is the header message, the message with the header comes into an inference engine using a Drill's inference engine. And we've got a rules library with a set of declarative data processing rules built into it. Their declarative rules get applied to the message header and continue to flow through to the controller. The controller then will control the data matching or the data processing rules that are being used for that specific tailored message based on those declarative rule sets. Now, there's 2 advantages of the way the architecture works from our perspective. The first is I do not have to wholesale change my architecture to drop this additional design pattern in. I can drop it in, start using it in anger, but actually leave the existing orchestration method in place alongside it, which is very advantageous and shows the flexibility of the architecture from that perspective. The other thing that really sits alongside this is it allows me to separate out the processing logic that's embedded in the platform from the processing logic that's really set in the rules base. And what we're actually in the process of doing now is separating out those 2 elements into separate organizational structures so that I can have a dev team that's focused on continuing to evolve the platform while separately having a data management function that's delivering the day-to-day business and has got complete control of the rules base independent of the platform, which hopefully should allow us to get that more improved focus, improved delivery time, and a better experience for the customers. So current status, phase 1 is complete. It's live and operational. The framework's in place and the system is transacting, and we're currently in the process of loading up historic data for the initial tranche of clients into the solution, and the system is performing as we expect. We launch the initial fraud proposition next month, which will be it going live to market. The phase 2 development for the next major iteration or the next major proposition, which is a external facing data cleanse, data processing function, is in development and is quite advanced at this point. And what we're also doing is we are prioritizing where we spend the continued evolution of the architecture. So again, this is strategy by stealth, and what we're currently working on is where we think we need additional performance, tuning the platform to get increased performance, working on getting an operational framework up and running that will give us resubmission of dead letter queues, et cetera, so building more of that around the edge of the solution. And then what we'll also be doing is deploying in the flexible dynamic binding. And then that'll be the next wave, and then we'll be on to a wave after that, and a wave after that for the proposition after that. So in terms of the learning lessons, what I'd suggest, these are the key lessons we've had highlight. The key thing probably is that the technology itself is not the value add in this architecture as far as we're concerned. It's absolutely about the architecture. So where we've seen, or where I've seen people fail with SOA in the past, is they focus far too much on the technology and not nearly enough on actually the design of the architecture. SOA is all about the architectural design. We spent a significant amount of time designing the framework, getting the analysis right about what our business need was, making sure that we had a really clean set of requirements, and we had the detail that underpinned the processing and the logic. And we use that really to drive the development of the framework. So it would be, whilst we've got a vision for what the end game of the architectural framework is, we've only really at this point deployed just enough architecture, just in time to provide our business need. And I would certainly recommend to anyone that it's essential to have a real world business requirement, which then can be used to drive the architectural piece. Because I don't know about other people in other organizations, but I certainly can't sit in front of the chief exec and go, give me several £1 million to build a framework that one day might generate some business revenue. So this is very much about how do we get clear benefit out of something that we believe to be the right architectural strategy for the organization. WSO2 has proved to be a really good platform for us. It's not in live business operation, but it is in live transactional operation. It performs well, it's stable, and it is, we'll see in another 6 months, but my expectation is it will prove to be a really good platform for what we're doing. I think the note of hesitation, I would say, is that there's comparatively few market skills out there. We've effectively had to grow all of our own competence in WSO2, which has taken us a considerable amount of time. I think it's well worth it for the nature of the project because it's a strategic direction for the organization, but it is something to be aware of. So the front end of our development has been comparatively slow, drawn out and long, but actually the tail end of our development, now that we've got up to a productive level, is actually being very successful and very fast. So I think there is definitely a clear learning curve to get up there. But in fairness, I would expect that with any of these technologies that you might use. And that's me. Any questions? Yes.
Can you talk about the process, business process that you said that you represented as orchestrating?
Yeah. So on the principle of just enough architecture, just in time, because what we do, the complexity at this stage of the development of the product is largely in the data processing rules, not in the business logic path. So we took the pragmatic decision to effectively code in Java a service that manages the orchestration, still driven by the header information, but essentially for each business process, we've created one Java service that is orchestrating that as a pragmatic way of moving through this first wave. One of the innovations we're going to do is the fairly obvious one, which is to put in a business activity monitor over the top of that and then replace that. But for us, at this stage, the complexity is the data manipulation, not the process. So that was the pragmatic compromise we've taken. So in the first iteration, so the question was it all automated or is there manual interaction? In this first proposition, it's all fully automated because of the nature of the proposition. In the second proposition we're putting in, although the runtime execution of the process is automatic, there is actually a manual step to set the process up. So in the second proposition we've got, which is effectively someone gives us their entire CRM database, and then we will process it to basically cleanse the data, augment it with defined variables, and then come back out the other end. What we do is we actually manually set that process up with the configurable data processing rules, and then there's a setup process there, and then we actually fire the engine up and then put the data into it. So, but if we did want to do a breakout for a user interaction, so for example, a decision process, I would just see us using an appropriate business activity monitor that could create a user interface as part of the step.
Hi, Phil. Just two quick questions. Have you considered the use of complex event processor and like creating bolts for your clients for fraud detection?
It's a good question, and I think it's one of the obvious questions that might come out of this presentation. We don't do that, but there's a very specific reason we don't do that, which is because we are essentially a one-trick pony that is just good at processing this personal identifiable information. We've effectively been building our algorithms to do that processing task for over a decade. So they're highly tuned, they're very specific to what we do. So we actually don't need to use complex event processing because effectively we've built our algorithms and built them up over many years to get them very highly tuned. And therefore we don't have that need to do that outbound piece because we've actually done the measurement of the analytics over many years to get the rules tuned in that sort of sense. So it would be a natural thing to put into the process if we hadn't had that sort of legacy of knowledge.
And just a second question. The business rules, the actual execution of those, is that done in the ESB, like a rules mediator?
So the business rules that are for the process execution are embedded into the orchestration service. The business rules that are particularly in the new rules engine, the data processing rules, actually sit in the rules declarative reference set. So we're actually literally, you drop in a new reference file and you've got a new process in terms of data processing. Any other questions? Okay, thank you.